Hello everyone. Now we have to find the energy stored in a magnetic field. Now previously we have taken whenever there is a change in magnetic flux linked with the coil, an induced EMF is produced in the coil. And this induced EMF is such as to oppose the rate of change of magnetic flux. Now that's why some energy has to be spent to overcome it to build up the magnetic field. In the previous chapter electrostatics, we have taken the electrostatic energy stored in a capacitor, and that energy is given by UE is equal to 1 by 2 Q square by C. But Q is equal to CV, so another equation we get UE is equal to 1 by 2 CV square. Now in this case we have to find out the energy required or energy spent to build up a current I in a circuit having the inductance L. Means if the circuit is having inductance, what is the energy spent? So for that we want the induced EMF produced in the inductance. This also we have taken previously. The induced EMF produced in the inductance or inductive coil is E is equal to minus L into di by dt, where di by dt is the rate of change of current and L is the inductance. Now what we have to find? We have to find out the energy spent. So for finding the energy spent, we have to find out the work done. So for that we have to consider a small charge dq and we have to move that charge. Then we can find out the work done. So the work done in moving a charge dq against the EMF is dw is equal to minus E into dq. This negative sign shows that the direction of flow of charge and induced EMF are opposite in direction. So see, in equation 1 we have taken the E. What is E? E is equal to a minus L into di by dt, so we can substitute here. So what we get then? Therefore dw is equal to what? Minus, in bracket, E is equal to again minus L into di by dt into what? dq. Minus minus becomes plus, so dw is equal to L into di by dt into dq. Now shift the dt to the dq. So dw is equal to what? L into di into dq by dt. But we know what is the rate of flow of charge per unit time. The rate of flow of charge per unit time, that is called as current. So we can substitute here now. So what is the work done by the charge dq? That is L into di into I, or that we can written as L into I into di. We write at I at the beginning. But we have to find out the total work done. So what is the total work done then? The total work done by the charge. The total work done is, what is the total work done? Is given by, that is by integrating this dw we get the total work done. So w is equal to integration of dw. So what is the integration of dw? dw we know what is that? L into I into di. Substitute here. So w is equal to integration of L into I into di. L is the constant, right out of the integration. So integration of I into di. Limits from 0 to I. Our minimum current is 0 and maximum current is I. So our limits from 0 to I. The integration of x with respect to dx, that is x square by 2. Similarly, the integration of I with respect to di, that is also I square by 2. So L into I square by 2. So what is the work done then? Work done is equal to 1 by 2 Li square. But we know this work done is stored in the form of energy. So this work done is nothing but the energy spent. So we can write that is equal to UB. So what is the UB then? What is the energy? Energy is equal to 1 by 2 Li square, and this is the energy stored in a magnetic field. Thank you.